roll the log. So e to the fifth equals 8x. Anytime you see log base e, it means ln. Same thing here. E to the eighth equals 5x. Instead of log base e, you write ln. 10 to the x power equals 2. 10 squared equals x. Roll the log. 3 to the 7th power equals 2187. If I see this right here, the base stays the base, so log base 3, the 2187, and 7 switch places. Remember that log base e of x equals ln x. If I have log base e of e, and I set that equal to x, e to the x equals e. So e to the x equals e. What's the exponent right here? It's got to be a 1. So if I see log base e of e, that means x equals 1. The other thing, we have lne. That means the same thing as log base e of e. Anytime these two are the same, it equals 1. So if I have log base 3 of 3, I set that equal to x. Then I would say 3 to the x power equals 3. What would the exponent have to be up here? It's got to be a 1, right? So x equals 1. Because the 3's can drop off and just x equals 1. So if we write this in log form, the base is e, becomes the base of the log, and the 4 and the x switch places. So we say log base e, we can rewrite that as ln. So ln x equals 4. It's good, I just started the recording and recorded all the stuff at the beginning. So we're good.
Okay. Awesome.
So
can we just like do it all
yes,
again?
for sure. So this one, right? We're going to take 2 to the x equals 16. So we're going from log form to exponential form to solve for x. So when it says evaluate, just set it equal to x. Okay. That's what you have to do. That's the only way to solve it, right? So I write 2 to the x power equals 16. And then I know that this is going to have a base of 2. So all I think in my head is I go 2 times 2.
4. 4 times 4 is 16.
No, 4 times 2.
4 times 2
is
8. 8
times 2 is 16. So how many 2's?
4.
4 of them. So we just say 2 to the x equals 2 to the 4th. And I'm just making that assumption, right? I have to.
So then you can say x equals 4.
Right, and then the 2's cancel and x equals 4.
Okay. So that's not what we got here.
So I would write it like that too. Like I like the arrows, right? Because it helps it like stay straight in my head.
Yeah.
Otherwise it gets all confusing. And you think if it's a base of 2, it's got to be multiple 2's, right? It's a base of 3, you're going to go 3 times 3 times 3 times 3, something like that. It's good because it's a short review.
Yeah.
So we can spend some time on it, right? Make sure you get it.
Okay.
All right. Do you get why this one equals 12?
Because if it's...
Not totally.
He explained it to me, but I don't know.
So if I write ln e, that means the same thing as log base e of e. And if I make this equal x, and then I rewrite exponentially, I'd write e to the x equals e. So e to the x power equals e. Well, what does the exponent have to be up here?
1.
1. So what does x equal?
1.
So what does ln e equal?
12. Okay.
Yeah, right?
Yeah.
Because that 12 comes down in front, the ln e just cancels, and it's 12 times 1 or 12. So x equals 12.
Okay.
So anytime you see ln e, I wrote it up here for you. Ln e equals log base e of e, right? So that equals 1. And I said anytime that these two are the same, it equals 1, right? Even if it's 3 of 3, it still equals 1, right? Because
Yeah.
if we rewrite exponentially, 3 to the x equals 3. Well, it's got to be 3 to the first power, so x equals 1. Okay?
Yep.
All right. So this one, they
Yeah,
give
this
you
one I
this
don't
weird little decimal.
get.
It's not that big a deal, right? So I'm looking at
Oh,
this.
I do understand this.
Oh, good.
Because to get 81, you do 9 times 9. So then that's the addition, because that's
So if we do,
multiplication.
here's another way to do it, just in case weirdness happens. Right? 81's 9 squared, because I have a 9 right there. And if I take this and put it down in front, then I have 2 times log base 6 of 9. And then log base 6 of 9 equals that. So I just say 2 times 1.2263. The way you did it totally works as well, right? Because I would
Yeah.
just add this plus this, plus itself essentially.
Yeah.
Or just multiply it by 2, either way. And the answer, I'll tell you what the answer is, just so we don't have
Yeah, I
to
didn't
do
write it
that
down.
silly math. 2.4526. 2.4526.
Okay.
Okay? How about this one? Minus means
Divide.
good. And then this becomes the exponent on the 2, or sorry, on the r. The 4 becomes the exponent on the r, and the 2 becomes the exponent on the y.
So is it log r to the 4th?
So log r to the 4th up top over y squared. So she wrote it like this with a little slam.
And then is that it?
Done. Because we're writing it as a single log, so you go from 2 logs to 1 log, and we went to 1 log right there.
Okay.
Okay? Now we're expanding, going the opposite. So instead of condensing, we're expanding. So you pull it apart. Where's that 7 go?
In front of the...
In front. So we have 7 ln m.
How do you know if it's ln or log?
Because it's ln right here.
Oh.
Okay? It's
Yeah.
a good question, right? Because it gets confusing. You're like, what the hell's even
Yeah.
happening anymore? I don't know.
So 7
And then
ln...
minus divide means minus.
Minus, yeah.
Divide and minus
Minus.
go together. So minus ln x. Just writing one ln for the numerator, 1 ln for the denominator.
Yeah.
Right? Done.
Okay.
Okay. So do you know how to put this? Do you have your calculator?
Yeah.
I think your calculator has this button. I hope it does. So hit math. Go up. It doesn't have it. All right, hold on. We got to do a different thing. So we can go. Let me make sure it's here. Yours does not even have it. Not cool. Okay. So this is what it works. Might be worth even borrowing somebody's calculator. So I can go here to log base. Oops, that didn't work. Math. And then see, I can put in the base.
Oh, that's nice.
So I can just, it's just because
Yeah.
your calculator's older, you can't. But whatever, it's still not a hard problem anyways. That is not what I wanted. This. So the way I remember this one is base goes on the bottom. And I just write that entire thing out. Base goes on the bottom. And the base is 6, right?
Mm-hmm.
So when I write this fraction out, I'm going to write log 24 over log 6. Now your calculator gives you the beginning parenthesis in between the log and 24. You just got to make sure to close it. And then I just plug that in and make sure you get 1.7737 around it.
Okay.
So log 24 over, close that parenthesis, over log 6.
1.77.
37?
Yeah.
Yep, good. Easy, right? And she told you in class that she made a mistake on this one, right?
Yeah.
So here's what happens. Because the whole function, so first of all, this negative flips it upside down.
Okay.
So a regular log graph, I'm just going to show you because it helps you understand. So a regular log graph, if I just do log x, looks like this. And if I flip this over the x-axis, it turns it upside down. So if I just go in here and I do negative in front and graph it, see how it flipped upside down? So reflect over x, and then I have x plus minus 2. Which way does that move it, left or right?
Right.
Right 2. So I'm just looking at the graph, see it moved it over 2, and then up 1.
Mm-hmm.
So plus 1. I just like doing it that way because you can see what each individual transformation does. Like it moved it, flipped it, right 2, up 1. Now,
Okay.
so let's start answering these questions. So domain.
All reals.
So if let's graph it first, and we'll graph it correctly, unlike Miss Voss. So you have 3, 1 is a point.
Positive 3.
Positive 3, positive 1 on y.
Okay.
And then 5.5.
Okay.
And then, so it's going to go, I would draw an asymptote here because of that minus 2. At plus 2, draw a dotted line in right there. You can use some of the colors if you want.
Oh, okay.
Purple is a good one.
I
That's
love
my wife's favorite color.
That's my favorite color
Good
too.
choice. You just can't screw up. That's the only thing when
Yeah.
you do it in pen. Like, shit, I did it wrong.
Yeah.
Okay, so then this thing travels up that asymptote, so you can just draw it, and it'll go eventually below, but it's going to stay above that line and go below after. Because, so if you're in your calculator, let me just plug it in real quick so you can see it too. So we have negative log x minus 2 plus 1. So, zoom 6. So there's your graph, right?
Mm-hmm.
So if we go second table, I don't
My
know why
plot
it
might
is.
be on.
It's not. I turned it off. It is second y equals. No, that's not it. I'm just going to reset it.
Okay.
It's the easiest way. So we go negative log x minus 2 plus 1 graph. And we go second graph. There we go. So 3, 1's a point. And then we're trying to find this intercept. We'll do that one next. So I just go down till x has a value and y is 0. Because a log graph will only cross the x-axis, it'll never cross the y-axis. That's
Okay.
not true. It could cross the y-axis, but generally it'll only cross the x-axis.
Okay.
Okay, so domain starts at positive 2 and goes to the right forever, so x is greater than 2. Any log function, the range will always be all real numbers. It has to be. I would write like always next to it so you remember. And then
And then asymptote is 2.
Asymptote's x equals 2. So when I think what the asymptote is, I just think which axis did it cross? It crossed x. Where did it cross it? X equals 2. And then you know for sure. So does the end behavior, are you good with that?
Yeah,
Let's see,
so
I'm gonna
as
cover
it
it up and
goes,
see.
as it goes
As x goes to positive infinity,
f of x goes to 0. Just it goes to infinity.
goes down forever,
Oh, goes to negative infinity.
right? So if we think about this, if we look at the calculator and we just keep going to, right? So as the x values are getting bigger and bigger, see how they keep going down?
Yeah.
So negative 0.7, we're at negative 1, so they'll keep going down forever. Super slow, but they'll keep going down forever.
Okay.
Whatever, let me just go back here, start that at 0, back to normal. Okay,
Okay.
so then
And then a
as
negative
x goes to negative, what
goes
happens?
to f of x goes to 2.
Yes, good. That messes with a lot of people's head getting
Yeah.
that 2. They're
That
like,
one
what the hell?
Yeah.
This one messed with you a little bit, but you can see it keeps going down forever, right?
Yeah.
So I think of that like going like that.
Okay. And then like, will the asymptote always be like this number, just the the opposite of that number?
Yes. Yes, it will. That is good. Okay, so that's that. That's that. Okay, so what's the next one? 11.
Solve use exact answers when possible. Otherwise, round to 4 decimal places. Show all work.
So when you have the same logs on both sides, they just cancel.
Okay.
And then we just end up with 12x equals x squared plus 20. So anytime you
Oh, and
see
then you
x
turn it
squared,
into a quadratic.
yes,
And then you check it.
yes. And I want to keep the x squared positive always, otherwise it's a nightmare to factor. So I'm
you
going to
subtract
subtract 12x, exactly. So you're thinking what multiplies to 20 and adds to negative 12. So 0 equals x squared minus
Isn't
12x.
it easier way to just enter it into your calculator as a
Do
quadratic?
20 divide. Oh, show me what you mean. Go second, quit. Yep.
Okay. Program. Where'd it go? Where'd it go? There used to be a quadratic on my program.
Quadratic formula.
Like, yeah, and then you could just enter it.
She'll make you show how to do it anyways.
Okay.
So look, 20, negative 12. And then all we do is this. We go second quit. We go y equals 20 divided by x. And then look at the factors. So which one adds to 12?
2 and 10.
2 and 10. So if it's that adds to positive 12, what do you have to do to make it negative? Just both negative.
Negative.
So we have x minus 2, x minus 10 equals 0. So x equals 2 and 10, right? If you set those equal to 0. So x minus 2 equals 0. X minus 10 equals 0.
And then both of them are like not extraneous because they're not negative.
Yes. Good.
Okay.
So not that bad, right? Because everything cancels. You just factor in a quadratic. Like, who the hell cares?
Yeah.
And she'd make you show all that work anyways. So at least you'd know.
Yeah.
You can download that thing again. I have the code that'll download that quadratic formula.
I don't know why it went away.
Because I reset your calculator. That's
okay.
why it went away. So I screwed you over right there. So
Come on.
sorry.
To teach me how to actually do
that's
the
not
problem.
cool. Yeah, it's kind of my job, but
Yeah.
you know. All right, so these guys. So let's copy these. This gives you a little anxiety, right?
Yeah.
It's okay. It's allowed to. All right, let me go. I have all that stuff. Let me clear this and add a page. The big sigh usually means anxiety. You're like, oh God, this is not fun. All right, so no base, always base
10.
10. And then we're gonna do that 10 squared equals 3x minus 1. What's 10 squared?
100.
100 equals 3x minus 1. And then it's just a little baby algebra problem, right?
Yeah.
Plus 1, divide by 3. So remember how she said exact answers?
Mm-hmm.
This is the moment for exact answer. So we have 101. That's not 101. 101 equals 3x. So we just divide by 3. And then the 3's cancel. This is your exact answer.
Okay.
Because in here, if I do 101 divided by 3, you get that you get it, or whatever. You would get,
Yeah,
I
a bad
missed
number.
it, but
Yeah.
you get a repeating decimal. So
Okay,
that's
so
why
that's
you just
it.
leave it like that.
Okay.
All right, so next one. So you see ln, you think
E.
log base e. Good. So we're going to copy this one. Put it over here. So I'm going to write log base e of x plus 4 to the 5th is greater than 10. I don't care about the inequality, like who the heck, it does not matter at all. It's the same damn thing. So e to the 10th greater than, I care about it to write it,
So e to the 10th
equals,
is
greater than, rather, x plus 4 to the 5th. How do we get rid of a 5th power? You take the 5th root. You know how to do 5th root on your calculator?
Yeah.
Good. So I'm going to plug that whole damn thing in my calculator. 5th root of e to the 10th. So 5 first. And then math, 5th one down. And then put in e to the 10th, so second ln.
Oh, oops.
Just delete, yeah, good. Second ln to the 10th.
So
So
7.389
7.3, you gotta go more, 7.3891. 3891, 4
Greater.
decimal places always.
is greater than x plus 4.
And then just subtract 4.
Minus 4.
So equals 3.3891. And I would always, you're about to put it in your calculator, especially on a test, always put it, you do
Yeah.
that anyways, right?
Yeah.
Yeah, it's good. You should.
Yeah.
Because you don't want to make, I get so mad when I'm grading kids' tests when they screw up subtracting those. I'm like, you have a calculator.
Yeah.
Use a calculator. What are you doing? You're missing problems that you shouldn't miss.
I
Like,
put
what the
everything in my
heck?
calculator
Yeah,
on tests
good.
because I'm just like, I'm
Well, you get,
not doing these things wrong right now because
you
I'm
just,
so stressed.
yeah, you freak out, right? So it just makes sense. Why wouldn't you put it in your calculator? Okay, so plus means what?
Multiply.
Yes. So we have log, what's 2x times 5?
10x.
10x equals 2. No base, it's always base
10.
10. And then we rewrite exponentially. So 10 squared equals 10x. So 10 to the second power equals 10x. 10 squared again, right? 100 equals 10x.
Wait, why is it 10x?
Because when we do, right, 10 to the second power equals 10x, like that.
Oh, so you skip the 2.
No, the 2's right here, right?
Yeah, but then after that
10
you skip
squared,
over the
yeah,
2.
yeah. So it'll mess with your head, right? Like you knew how to do that, and then all of a sudden you're like, wait a minute,
Yeah.
how does that work? But that's your confusion, right? So once you do this again, then you'll be less confused. Do you ever wake up early and study for a test? Can you do that? Like I used to do it all the time when I was in high school.
Yeah.
Like I just get so gassed. Like after we have this session where we're like fast paced for an hour, your brain's like done, right?
Yeah.
So you like watch a movie or something, go to bed a little earlier, wake up at whatever time, like you need an hour to do this again.
Yeah.
Wake up an hour early and just do it again.
Yeah.
Can you do that?
Yeah.
Yeah, good. I was the same way because I'm like, I'm just cooked right now. I can't
Yeah,
think,
I
right?
can't.
I'm just like mentally fried.
So then is x 10?
Yeah, x equals 10, exactly. So ln 3x This one's just a little trick. That's the thing, they'll get you with this stupid little tricks, right? And you're like, I don't like you. All right, so minus means,
5.
so I have ln 3x over 5. And I write that like a fraction next to ln, and it equals 0. How can I rewrite ln?
E.
Log base e of 3x over 5 equals 0. Now we're going to go exponential. Tell me how to do it.
Okay.
Look. E to the what?
Oh.
It's still
E
shaky.
to the power of 0,
Equals
3x,
over.
5.
Yes. So draw those arrows. They'll help you, right? Because it'll solidify that pattern in your head. And you could even draw those arrows in a different color because then you'll be happy because you see purple.
I think I wrote it wrong. So then,
So e to the 0, I draw an arrow from e to 0 and from 0 to 3x over
can I
5.
use a different?
Yeah, use any color you want. That's why I got my handy little pencil bag, so they're not easy to get out though.
That's okay. So it's that.
And once you get used to drawing that every time, let's go back and draw more of them just so you get it.
Okay.
So let's flip to this side. We can draw. So draw down here, 3 to the 7. So we're going this way, we're going backwards, right? So 3 to the 7 equals
7.
2187. And then you can look over here and you're like, yes, I got it right. Right? So same thing over here, e to the 4 equals
X.
so e to the 4 equals x.
Yeah.
Bam, right? So then I would like cancel this, go that way, right? Log base 3 of 2187 equals 7, right? Because the base is always a base. These two switch.
Okay.
Base is always a base. These two switch. Right? So whatever way works best in your head. Like for a while for me, it was base is a base switch. And it works both ways, whether it's exponential to log or log to exponential. But I also like the arrows, right?
Yeah.
Because I think of it like twisting backwards.
Yeah.
And then I'm like, okay, I get it.
Right.
This one, well, no, that's really it. Because these ones are weird, right? Base is a base, but then they switch it to ln. So it's like a double switch.
Yeah.
So that's why I wrote that one with the log base e thing, right? So log base e. So you see e to the 5th equals 8x. E to the 8th equals 5x.
Okay.
That's where that roll thing will help you, or just drawing the arrows will help you.
Yeah.
All right.
That makes sense.
Go. And we're on this one. So new.
So is this one 4 to the 95th equals 2x?
Now, so the whole purpose of logs is to solve for an exponent.
Okay.
That's why we do it. So log functions and exponential functions are inverse of one another. So when we do this one, it's a whole nother concept. So let's do this down here. Let's actually add a page. Put it in here, put this one here. So when I see this thing, I just go log at the beginning and log right here. So this is called taking the common log of both sides. And we can do, what it helps us do is find the unknown exponent. So this 2x goes in front, right? So we end up with 2x log 4
equals
log 95. So then I can look at this thing I want to solve for x. So I'm going to divide by 2 log 4. So when you put this in your calculator, the key, I like putting the whole damn thing in my calculator, right? So it gives you this first parenthesis right here. You got to make sure you close it. And then the key is you got a beginning parenthesis here. It gives you this one, and you have to double close at the end. I would do colors on that thing too.
Yeah. So log 95.
So log 95, divide,
by 2.
parenthesis first, and then 2 log 4. And double close that. One more. Oh yeah, you did. Never mind. Good.
1.6.
And then I think it's always gratifying to see the correct answer, right? 1.6425. Okay.
Yeah.
All right, so this next one is a doozy. So you need to write super small or write it on another piece of paper. Just see how much stuff's in there.
Yeah.
Yeah, it's
I'll
just
write
kind
small.
of unpleasant. Okay.
Okay.
So let me copy this. So we're going to take the common log of both sides, so you can start there.
So we'll do log 3 to the 6y is greater than 5 to the power of y plus 2. Or the log.
And the 6y is going to go in front.
Log.
So 6y log 3
Oh.
greater than y plus 2. It's got a trick to it, this one too, which is kind of evil. It's actually not that bad. So
Okay.
I'm just remembering that goes in front, right? So you got the log and the 6y goes in front and this goes in front. And then when I'm thinking about this right side, I'm distributing that log into both parts of that parenthesis. So distributing backwards. So we get 6y log 3 greater than y log 5 plus 2 log 5. This one's good to like pause and like, it's gonna be okay, I'm gonna get this. Like, so when I have two y's, right, I've got y's on both sides. I want to get the all the y's to one side because then I can factor out a y.
So do you subtract?
So subtract y log 5. Perfect. Minus y log 5. So if it's not the case here, these were the same numbers right here, I could subtract these two. But because they're not the same numbers, then you're stuck and you have to factor. So right here, we get 6y log 3 minus y log 5 greater than 2 log 5. See, there's no way you can fit that thing in there because there's still a good amount to go.
Okay.
Like not quite that much writing, but almost. So now we have y's, right? We have a y here and a y here. So when I see that y, I can factor. So I'm going to divide. I like showing it like this. Divide by y on both. Smart. I like the sticky. It's good. So as soon as I do that, then I can write the y in front because I factored it out. And I have 6 log 3 minus log 5. And then greater than 2 log 5. Now this part right here, I just put that right into your calculator. So in your calculator, do 6 log 3 minus log 5. And I put this one in my calculator too. Like with it, because as soon as we have just log and a number multiplied, like who the hell cares? You can put the whole damn thing in there.
Minus log 5.
Log 5. So we get
2.1637.
2.1638 rounded.
Oh, okay.
So 2.1638 And we have that y in front, right? So I'm going to keep that in parentheses. And then let's do 2 log 5.
1.39.
3979. 1.3979. Okay, and then I'm going to divide both sides to get the y by itself. So divide by 2.1638. If this was ever a when are we ever going to use this moment, this is what that moment. You're like, wow, who cares?
Okay, so point
6461. So y is greater than 0.6461.
Yep.
Okay. And then, so see, she didn't round correctly, so whatever. This is 10 thousandths place, so who the hell cares, right? Our answer's more right than hers. That's all that matters.
Yeah.
Okay, last two.
Let's go.
See,
Okay.
it's not that bad.
No.
So I want you to read this thing. Just read the whole thing and before you read it. So this is how I look at these problems. I try to find an equation. I'm like, sweet, I don't have to work that hard.
Yeah.
And then I'm like, there are only 2 other numbers, so I just got to figure out where they go. Well, that number's already there, so I cross that out. This is the only number. I have to figure out where it goes.
Okay.
So I set the stage when I'm reading the problem, so it just de-stresses me, right? This one's more of a bitch.
Yeah.
The next one, we'll get there. But
Yeah.
look at this one.
Okay.
We're going to figure out where that 100 goes. And underlying is key.
So is it 100 equals 200?
Yes. See, but like if you break it down like the way I'm thinking
Yeah.
about it, I see the equation, I see the 200 and the 100. I'm like, sweet, I only have to figure out 2 numbers. That's fantastic. And it's 100 milligrams, so it can't be time, right?
Yeah.
So your first step is what? Oh yeah, write it. Hold on. E to the negative 0.4 t. This
Yeah.
up a smidge.
Okay.
So
And
what's your
then
first step?
Subtract 200.
So what's the
Or divide?
operation? Yes, good. So divide by 200 both sides. So you get 0.5 equals e to the negative 0.4 t.
Okay.
And anytime you see a variable in the exponent, I would write ln in front and ln right there. It'll help you just pop. And then you remember ln e equals what? Of e, which equals 1. Yes. So this cancels. I draw a line through that, and this goes down in front. So it's the 0.4 t times 1, which is negative 0.4 t. Okay, so I can put this in the calculator. ln 0.5.
0.693.
So write negative 0.69. See, she didn't. Oh no, it's negative 0.636931. And then that equals negative 0.4 t. So what do you have to divide by?
Negative 0.4.
Negative 0.4. So you got that number in there, just divide by negative 0.4. So you don't have to write it again.
So then 1.7.
1.7328 or 329 because it'll round up. And that's how many hours it'll take for the medication to go from 200 to 100 milligrams.
Okay.
Boom, done.
Nice.
Beautiful.
Okay.
Read this one. So again, I'm scanning. I'm like, oh crap, there's no equation. honestly, the first time I did this, I had no idea how to do it.
Okay.
Just to give you some faith.
Yeah.
You're like, oh shit. But read it, and we'll talk about some key verbiage that'll help
Okay.
you like know what to do.
Is this like the y equals a e kt? Oh.
Exactly.
How do you, like-
That's exactly how I thought about it. Okay, we're going to talk about key stuff. So key thing to underline is the 15%. Right? We know we have half as much carbon-14. Don't underline that. Contain when it was made. Given that the decay is the next keyword, constant is the next keyword. Because constant is what tells you to use the E. Okay? And then of carbon-14 is 0.0012. So that's another little key. Put that there. Okay? And then, so first thing we got to do is take 15% and divide it by 100. Because then we get 0.15. And I will always write it like 0.15. The only reason I put the zeros because sometimes you miss a decimal and you're like, damn it,
Yeah.
I shouldn't have missed that. So constant means E. So I'd write E equals and draw an arrow to constant like that. So decay means it's going to be negative. So I'd write negative for decay. So 0.15 is the answer. And then we have E because it's constant. And then negative 0.00012T.
Okay.
Unpleasant. Definition of unpleasant. So we see E and we have to go ln at the beginning before each one. So ln. We know ln E equals
No, like 1.
1, nothing, right? And that negative 0.00 nonsense is going to go in front. So we do ln 0.15, 0.15 equals negative 0.30, so 12 and a T.
And then divide.
And then we're going to divide
Oh.
by negative.
But wait, don't first. You have to find ln. 0.15.
Yep, but you can just put this whole damn thing in your calculator,
Oh, okay.
right? So negative 0.12312 divide by negative 0.00012. That cancels. We have T. And then it's an absurd number of years once you get it. You miss a negative before you hit divide.
Negative.
Hold on. Let's go second enter. And we're going to go back to right there and go second insert. INS right there. Put a negative. Perfect. Wait,
Oh.
I just saw it. See, the negative's in the wrong spot. I just screwed up. So we want to put it right there. Second insert negative.
Okay, there we go.
So we get 15,809 years.
Awesome.
That's a long time.
Yeah, that is a long time.
So carbon-14 takes forever to like dissipate, like get rid of itself. So now problem solving on the test, right? So have you noticed if she gives you a nasty problem like this, it might be the exact same one on a test, right? So I would think, so that's why when we went through this, I'm like key stuff, 15% decay is negative, then 0.0, like that means E, so all that stuff, right? She'll probably just switch the numbers up and the problem would be the exact same, right? This one's doable. No problem. You look for the equation, figure out where those two go. No problem. That one's already there. That's got to be the answer. Done. Right? So this one, you get like, you might get lucky and it's the exact same problem and you're like, oh, thank God. And you still might get confused writing
Yeah.
it.
Yeah.
But if you could get a point or two, you can still get an A or B on a test,
Yeah.
right? What's your grade in there right now?
I think like an 85.
Nice. Good. If you ended with a B, would you be happy?
Yeah.
Yeah?
I mean, I just
you'd
don't-
want an A, obviously,
Yeah.
but you don't
I
want a
know.
C.
No.
Yeah.
I mean,
So
the B would be fine.
it'll come down to the final, right?
Yeah.
So if you can go 85 and you can get like 85 or higher on this test, you always do your homework,
Yeah.
right? So like that'll start creeping up.
Yeah.
You get to like 86 or 87, then like you could get a 55 on the final and still keep it beat.
Yeah.
Because you know she's
I wish she
hardcore.
rounded.
I know.
So annoying.
I know.
Whatever.
I've literally screamed at her before about rounding. I'm like, why don't you're a fucking math teacher? How
Yeah.
can't you round? Oh my god.
Yeah.
And she's like, no. Exactly what you'd expect, right?
Yep.
You're like,